In this video, we will show that the two definitions of an ellipse are equivalent. We will start with the definition that of an ellipse that of all the points for which the sum of the distances to the two foci is constant, and end up with the second definition, which is a squashed circle. So let's start from this definition, and we showed in a previous video that if we start from this definition, we find a simple relation between the distance to one of the foci and the projection on the x-axis. You can click this link to see this derivation. Just squaring this equation, we find this relation between r squared a and x and e and x. On the other hand, just using the Pythagorean theorem, we can relate this r to y squared plus x minus this ae squared, which is this part. So this part squared plus y squared is r squared. This is what you see written here. Written here. We just open the parentheses and we find this expression. And now we just move. So the only part which is unwanted here, which involves x and not x squared, cancels between the two sides. And when we gather the terms, we arrive at this equation. If we use the fact that the semi-minor axis is related to A in this way, which is directly can be directly seen by viewing this triangle. So this is the semi-minor axis, and since the sum of the distances to the two foci is always constant and equals to 2 times A, this part of the triangle has to be A, and then again using the Pythagorean theorem, we can relate B to A and the eccentricity in this relation. And now if we just divide, so this on the left hand side is just B squared. If we divide by B squared, we arrive at the squashed circle equation for the ellipse.